everyone. This problem has been asked in GATE 2023 and this problem relates to electrical machine part and this is from the transformers. So the problem says that when the winding CD of the single phase 50 Hz two winding transformer is supplied from an AC current source of frequency 50 Hz, the rated voltage of 200 volt RMS 50 Hz is obtained at the open circuited terminals AB. The cross-sectional area of the core is 5000 mm square and the average core length traversed by the mutual flux is 500 mm. The maximum allowable flux density in the core is 1 Weber per meter square, that is 1 Tesla, and the relative permeability of the core material is 5000. The leakage impedance of the winding AV and the winding CD at 50 Hz are given so on respectively. Considering the magnetizing characteristics to be linear and negligible, neglecting core loss, the self-inductance of the winding AV in millihenry is. That answer should be round up to one decimal place. So here, if you want to go through detail detailed concept of self-inductance, mutual inductance, leakage inductance in transformer, then you can kindly refer this lecture, NPTEL lecture, that is module 1 lecture 2, operating principle of and construction of single phase transformer, and this NPTEL course name is Electrical Machine 1 by Professor D. Kastha, Department of EE, IIT Kharagpur. And I have also given this YouTube link for this lecture. Now, before we start to solve this problem, let us have a quick recap on the mutual inductance. What is mutual inductance? Because here we need to find the mutual inductance. So mutual inductance is defined as you can define in two ways. In the first, I am defining with respect to secondary coil, and in the second, I, I will define this mutual inductance with respect to primary coil. So in terms of secondary coil, how can define the mutual inductance? Mutual inductance is the ratio of flux in linkage with secondary coil due to primary current to the primary current. Therefore, flux linkage will be turns ratio into flux. So therefore, N2 multiplied with flux due to primary current divided by primary current. And flux is nothing but it is the ratio of MMF and reluctance. And MMF due to primary current will be turns ratio of primary binding into the current flowing through the primary binding. So N1 I1 is the MMF due to primary current and reluctance is L divided by mu A. On putting all these value, you will get mutual inductance as mu N1 N2 into A divided by L. Now in terms of primary coil, how can we define the mutual inductance? So mutual inductance is the ratio of flux linkage with primary coil due to secondary current to the ratio of secondary current. So flux linkage with primary coil will be it is the turns ratio of primary coil. We have denoted it as N1 and into flux due to secondary current, and flux is nothing but MMF. Flux is nothing but the ratio of MMF and reluctance. Therefore, MMF due to secondary current will be N2I2, and on putting all these values, you will get mutual inductance as the same value as the previous one. In the previous case, we are also getting the same mutual inductance, and in this case, you will also get the same mutual inductance. You can find the mutual inductance in any of the page. So, we will use this expression in solving this problem. Now the coming to the now coming to the self inductance. So you can define the self inductance of primary coil and secondary coil in these ways. So first we are going to see the primary coil. So we can see that self inductance of primary coil L1 is the summation of leakage inductance plus mutual inductance. So you have to take care of the thing that you have to consider the mutual inductance that should be referred to the primary side and the leakage inductance as it is. So self inductance of primary coil will be L1 is equal to LL1, that is leakage inductance of primary coil, and M into N1 divided by N2. It is nothing but mutual inductance referred to the primary side. Now coming to the second point, that is self inductance of secondary coil L2, that is the leakage inductance of secondary coil LL2 plus mutual inductance referred to secondary side. Therefore, you will write this self-inductance of secondary coil L2 as LL2 plus M into N2 divided by N1. So in this problem, we have to find the self-inductance of binding AV. This is the this is the requirement we have to find. So based on this, we have to find LAB. In this question, we can see that leakage inductance of binding AB is given. How it is given? You can see here. Here you can see that leakage inductance of leakage impedance is given. So this will be AB. This LLAB leakage inductance of binding A will be 0.16 Henry. So this is the requirement for our solving the problem. And for similar, for you can also write this leakage inductance of CD is 0.36 Henry. This is not required here, but it is given in the problem. And MB will also find. So here we can see that we first need to find the turns ratio binding AB. Then how you will find the turns ratio binding AB? For finding the turns ratio binding AV, we are given with the open circuit voltage of the binding AV. From there, by applying this EMF equation, that is root 2 pi f NAB phi, we will get the turns ratio of AV. And these are the given values, that is cross sectional area of the core and length of the traverse. Length traversed by the mutual flux is 0.5 meter and maximum flux density is 1 Tesla and relative permeability is 5000 and leakage inductance, as I told you, of binding AV is given as 160 millihenry. So first we will convert this millimeter unit into meter so that there will be clear answer. There will be not confusion while solving the problem. Therefore, we can find this turns ratio of binding AB by using this EMF equation. So all these things are given. Frequency is 50 and flux density, maximum flux density is given as of the maximum level of flux density given as 1 bar per meter square. Area, cross sectional area of the core is given as 5 into 10 to the power minus 3 meter square. Therefore, you will get the turns ratio of binding AV as 181. Now we will find the second expression, that is mutual inductance with respect to binding AV. Therefore, we will get mutual inductance referred to binding AV as, you substitute all these values, you will get mu naught mu r n square A divided by L. Mu naught is 4 pi into 10 to the power minus 7. Mu r is 5000. Turns ratio is 1. Turns number of turns is 181 whole square, and A is 5 into 10 to the power minus 3 meter square. L is 0.5 meter. So therefore you will get the mutual inductance referred to the binding A will be 2058.43 millihenry. On putting all this mutual inductance value here, this we will get the self inductance of binding AV as leakage inductance is given as 160 millihenry and the mutual inductance referred to the binding AV will be 2058.43 millihenry. You will get the answer as 2218.43 millihenry. Therefore, the final answer for this problem is 2218.4 millihenry. That's all. Thank you.